Good morning to all of you. Today we are going to start the new chapter Acids, Bases and Salts, and it is the most important chapter for class 10. Acids, bases and salts, these are the three main chemical compounds. These also act as electrolytes, and we know that the substances which when dissolved in water conduct electricity are the electrolytes. We will read about these three one by one. First, about the acids. The word acid, it is derived from the Latin word acidus, means sour. Now about the general properties of the acids. Taste sour, changes the color of litmus from blue to red, conducts electricity, reacts with metals such as zinc, magnesium, etc., liberating hydrogen gas. So these are the some general properties of acids. Now about the classification of acids. Acids are often classified on the basis of source, strength, concentration, presence of oxygen, basicity, etc. Now the classification based on source. On the basis of this, acids are classified into two categories. One, it is the organic acid, another it is the inorganic or mineral acid. First, the organic acids. Acids present in plant materials and animals. For example, acetic acid, formic acid, lactic acid, oxalic acid, etc. These are the examples of organic acids. Second one, it is the inorganic or mineral acids. These acids are derived from minerals occurring in nature. For example, hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, etc. These are the examples of inorganic or mineral acids. Now about some naturally occurring acids. In vinegar, acetic acid is there. Chemical formula of acetic acid, it is CH3COOH or C2H4O2. In case of ant sting, formic acid is there, having the chemical formula HCOOH or CH2O2. In tomato, oxalic acid is there. Chemical formula of this oxalic acid, it is C2H2O4. In apple, malic acid, chemical formula of this malic acid C4H6O5. In sour milk, particularly in curd, lactic acid is there, having the chemical formula C3H6O3. In lemon, citric acid is there, and chemical formula of citric acid, it is C6H8O7. Now the classification based on concentration, that is the amount of the acid present in the solution. On the basis of this, acids are classified into two categories. One, it is the concentrated acid, another it is the dilute acid. In case of concentrated acid, there is the minimum amount of water and maximum amount of acid, whereas in case of dilute acid, there is the maximum amount of water and minimum amount of acid. So here two categories, one it is the concentrated, another it is the dilute. Now about the dilution of an acid, means how a concentrated acid is to be diluted. For this, acid is added to water with constant stirring, as the process of dissolving an acid or a base in water is highly exothermic one. We have read about the exothermic reactions. In this case, the acid is added slowly with constant stirring. For dilution, the water is not added to acid because in this case the content may splash out, or due to excessive local heating the container or the beaker will may break. Therefore, acid is added to water and not the water to acid for dilution. Now, what happens when an acid is added to water? When an acid is added to water, it splits or produces H plus or H positive ions. This H plus or H positive ion is a bare proton and therefore it exists as H3O positive or hydronium ion. Now consider this case. Suppose this H positive ion it is produced by the acid in water. This H positive ion will combine with this H2O molecule and will exist as hydronium ion H3O plus or H3O positive ion. Therefore, one of the definitions of acid, a number of definitions are there, but one definition of the acid it is the compound which produces H positive ions when dissolved in water is called an acid. Now, since acids produce H positive ions in water, therefore greater the number of H positive ions produced by the acid, stronger is the acid. And therefore, on the basis of this, that is the based on strength, that is the number of H positive ions produced by the acid, acids are classified into two categories. One it is the strong acid, another it is the weak acid. In case of strong acid, the acid dissociates completely or almost completely in water so that maximum number of H positive ions will be produced and the acid is strong. Whereas in case of weak acid, the acid dissociates partially in water and as a result lesser number of H positive ions are produced. So here two types, one it is the strong acid, another it is the weak. The strong acid dissociates completely or almost completely in water, whereas weak acid dissociates partially in water. We can take the example of strong acids and weak acids. For example, HCl, H2SO4, HNO3, these are the examples of strong acids. Consider this case. Suppose HCl in aqueous solution, it produces H positive ions along with Cl negative ion. In this case, the dissociation of the acid it is almost complete dissociation. Similarly, in case of H2SO4, H positive ions are produced. In case of HNO3, H positive ions are also produced. So, in these acids, the dissociation of the acid it is almost complete dissociation and hence are strong acids. Now about the weak acids, for example CH3COOH acetic acid, HCOOH formic acid, H2CO3 carbonic acids, these are the examples of weak acids. These acids dissociate partially in water, means lesser number of H positive ions are produced, means some part of the acid it will remain undissociated in the aqueous solution and as a result lesser number of H positive ions are produced and the acid it is the weak acid. For example, suppose CH3COOH, although it is producing H positive ions but due to partial dissociation lesser number of H positive ions are produced. Similarly, in case of HCOOH, also H plus it is produced by the acid. So in these cases there is the partial dissociation of the acid in aqueous solution and lesser number or very less number of H positive ions are produced and these are the weak acids. Now the classification based on the presence of oxygen. On the basis of this, acids are classified into two categories. One it is the oxyacids, another it is the hydracids. In case of oxyacids, oxygen is there in the composition, means oxyacids consist oxygen in their composition. For example, H2SO4, you can see here in the formula oxygen is there, so this is the example of oxyacid. In HNO3 oxygen is also there, so it is also the example of oxyacid. In case of hydracids, the oxygen is not present there, means hydrogen combined with other elements and not oxygen, not with oxygen. For example, suppose here HCl, oxygen is not here but it is the acid, so it is the hydrocid. Similarly Hi, HBr, these are also the examples of hydracids. Now the classification based on basicity of the acid. On the basis of this, acids are classified into monobasic acid, dibasic acid and tribasic acid. In case of monobasic acid, number of replaceable hydrogen ion is 1. For example, suppose HCl. Here number of replaceable hydrogen ion it will be 1. So it is the example of monobasic acid. In case of dibasic acid, number of replaceable hydrogen ion it is 2. Consider this case H2SO4, means one molecule of this H2SO4 dissociate to give 2 H positive ions, so it is the dibasic acid. In case of tribasic acid, number of replaceable hydrogen ion it is 3. Consider this case H3PO4 phosphoric acid. It will dissociate in 3 steps and will produce 3 H positive ion. So it is the example of tribasic acid. So monobasic acid, dibasic acid and tribasic acid, these are the 3 types of acids and it is classified on the basis of their basicity. Okay, thank you. Next we will discuss about the chemical properties of acids. Thank you, take care and have a good day.